All right, welcome again. This time we have to evaluate the derivatives of y is equals to natural log of x, y is equals to xy squared plus x, and y is equals to e to the 2x, all right? So thank you. Let's get the solution here. Right, so the first one, when you're told to evaluate the derivatives, we are told to differentiate y is equals to a natural log of x with respect to x, and that's very simple. We're going to have y is equals to 1 over x, right? So that when you integrate, that goes back to that. That's very simple. Number two, this is going to be an implicit differentiation. So we're going to differentiate with respect to x. So the first one is going to be on the left hand side, that is going to be y prime, that is translated to be dy dx, equals to this one. We integrate with the differentiate, using product rule. So we're going to differentiate this, hold this one constant. We're going to have y squared plus, we hold this one constant, we differentiate that, we're going to have 2xy, then y prime plus 1, right? So we put the functions or the terms with derivative together. We're going to have y prime minus 2xy, y prime equals to y squared plus 1. And this is going to allow us to factor y prime out, and we have 1 minus 2xy equals to y squared plus 1. And that gives us y prime equal to y squared plus 1 all over 1 minus 2xy. That checks. The last one we have uh, y is equals to e to the 2x. So the derivative of this is going to be y prime. I should have said y prime here. So y prime here we got 2e to the power of 2x. And that's how it is done. So we need to consider the following whenever you're told to differentiate a function like this, because this is the most tricky one among the three. You're going to differentiate implicitly, because here we have a function of y involving y on the other side. So this is not purely dependent on x, but also depends on y. So we are going to use product rule here to differentiate. So you differentiate this, holding this one constant, and so on, using the product rule. Thank you.